Next, we look at the potential energy of a system of point charges, or a group of point charges. And the starting idea is that we start with nothing. So there's nothing in a certain region of space. We bring in a single charge, Q1, and hold it in place. Once we have that, then Q1 creates a potential field around itself. Then we bring in Q2. And so we bring in Q2 from far away and put it down here, Q2, and then the distance between Q1 and Q2 is going to be called R12 because we're going to add more charges and we want to keep these distances separate. So we have R12 as the distance between Q1 and Q2. Essentially then, what happens is that the potential energy between these two charges, I'm going to call U12 because it's between this pair of charges, is equal to K times Q1 times Q2 over R12. So U12 is the potential energy of Q1 and Q2 together. R12 is the distance in meters between Q1 and Q2. And the units for the potential energy, again, are joules. The units for the distance are meters. K is the constant. Q1 is the first charge. I guess I'll call that charge 1. And the units are in coulombs. Q2 is the second charge that we just brought in. The units are also coulombs. At this point, once these two charges are close together, if we leave Q1 fixed but then let go of Q2, we can release that stored potential energy, and then we can actually figure out the kinetic energy that Q2 would obtain as it releases or as it converts the potential to kinetic, and we could find a speed later on. The next step is to bring in another charge, Q3, and then that will actually store more energy. So I'm showing Q3 in red. Now Q3 is going to feel forces from Q1, a distance that I'll call R13 away, and Q2, and I'll call that distance R23. So when we bring in Q3, we have two different effects to consider. We have U13 as the potential energy between 1 and 3, so that's K times Q1 times Q3 divided by R13. And we also have U23, which is equal to K times Q2 Q3 over R23. And then the total energy is the sum of all of the potential energies. So the total potential energy, or the net potential energy, then is equal to U12 plus U13 plus U23. Adding a fourth charge, Q4, stores even more energy. And I'll add Q4 in green. So Q4 feels the effect from Q1, Q2, and Q3. And then for the total energy of this system of point charges, we would have to add these three energies as well. And so the total energy, or the net potential energy of a system of point charges, can be considered to be what you would get first when you bring in one at a time. And you can see then as you add them how you have to add up more and more interactions. For example, if we had a fifth charge, we would have 4 different terms to consider. But you don't often have to do that on exams, again, because it makes the math more tedious instead of making the physics more interesting. But so then the total potential energy of the system of point charges is what you get when you bring them in one at a time, and we think of that when we calculate it, but it's also the energy that you would get if you then released all of the charges, because we have to fight the natural electric forces in order to bring this configuration of point charges together. And then if we let them go, those electric forces are going to cause the charges to fly apart or together in different ways, and it's going to release the potential energy that we've stored in putting them there.